Hello friends, I welcome you to my YouTube channel MaxPM. So in this video we will solve a numerical problem which is based on we will solve two numerical problems which are based on the velocity potential function and stream function. Okay, so let's read the first problem first. The velocity potential function is given by phi is equal to 5x square minus y square. Calculate the velocity components at the point 4, 5. So xy is given as 4 and 5. Okay. Now if you remember the definition of the velocity potential function in our previous video, then you know that its derivative in any direction del phi by del x, negative derivation in any direction gives the velocity in same direction. Okay, so minus del phi upon del x is equal to u, and minus del phi upon del y is equal to v. Okay, so minus del phi upon del x, so del upon del x 5x square, so 5x square minus, you can write like this. Okay, so 5 is constant, so it will come out minus 5 del upon del x, x square minus y square. Now if we are taking partial derivation with respect to x, then y will become constant, so it will become minus 5 del upon del x is del x square upon del x is 2x minus del y square upon del x is 0, because if we are taking partial derivation with respect to x, then only x will be considered as variable and y will become constant. So it is equal to, if we multiply these two, then we will get minus 10x. Okay, now v will become minus del phi upon del y, so it will become like this, minus 5 will be out, and del upon del y x square minus y square, so it will become minus 5 del x square upon del y square will become, y will become 0, and this will become minus 2y, so it will become 10y. Okay, so u is minus 10x, u is equal to minus 10x, v is equal to 10y. Okay, so we had to find the velocity at 4 and 5. So x is equal to 4 and y is equal to 5. So u is equal to minus 10 into 4 is equal to minus 40 units. Okay, similarly v is equal to 10y. So 10 into y is 5, so it is equal to 50 units. Okay, so this is our answer for the first question. We had to find velocity component, so we have calculated. We are not asked to calculate the resultant velocity, so we left it up to it there only. Now let's see the second question. Sorry. So this is our second question. A stream function is given by psi is equal to, psi is given as 5x minus 6y. Calculate the velocity components and also magnitude and direction of the resultant velocity at any point. The point x and y are not given. Okay, and one thing more is that we have to find also calculate the component and also magnitude and direction of resultant velocity. In first question we were not asked the resultant velocity. So if you remember the definition of the stream function, then you will remember that its derivative in any direction gives the velocity perpendicular to that direction. So we are differentiating with respect to x, but it is giving in velocity in y direction. Similarly, del psi upon del y is equal to minus u. Only sign you have to remember. Okay, now del psi upon del x is equal to v will be equal to del upon del x 5x minus 6y, so it will become 5 because y will be constant, so this component will become 0. Okay, similarly del psi upon del y, or u will become minus del psi upon del y, so it will become minus del upon del y, and psi is 5x minus 6y. So here x will become constant, so del it will become 0, and del upon del y for minus 6y will become minus into minus 6, so it will become 6. So u is 6, u is equal to 6 units, and v is equal to 5 units per time or per second, or you can write anything because unit is not given. Now what is the resultant velocity? It will be equal to root u square plus v square, so it will become equal to 6 square plus 5 square, which is 36, plus 25, which is equal to root 51. It will be 7.81 units per time. Okay, so this is resultant velocity. What will be direction? Direction is given that theta is equal to tan inverse v by u. Okay, so it will be tan inverse v is given as 5, u is given as 6, so it will become tan inverse 0.833. So if you will find its value, then theta will become 39 degree 48 minute. Okay, so this is our direction, this is our resultant velocity, and these are velocity components. Okay, one thing you have to remember, that it was asked at any point, so there is no value of x and y here, it is constant at all the points. Okay, that's why we could calculate easily. If these were function u and v were function of the x and y, then velocity will be different at different points, but here velocity is constant at all the points. Okay, I hope you understood this problem. If you have any doubt, then you can ask in the comment section, and if you like this video, then please share and subscribe. Thank you for watching.